Imagine harnessing the same energy that powers the sun. Limitless, clean, and nearly pollution-free. In China, scientists are racing to make this dream a reality, with a project often referred to as the artificial sun. This isn't a celestial body. It's a groundbreaking fusion research initiative, with the most notable reactor being the EAST Tokamak in Hefei, Anhui Province. EAST stands for Experimental Advanced Superconducting Tokamak, and in 2021 it made headlines by sustaining plasma at a staggering 158 million degrees Celsius for over 20 minutes, 5 times hotter than the core of our sun. So, how does this work? At its core, EAST aims to replicate the nuclear fusion process that occurs naturally in stars. Unlike nuclear fission, which splits atoms, fusion combines hydrogen isotopes, like deuterium and tritium, into helium, releasing massive amounts of energy. The challenge lies in creating the extreme heat and pressure necessary to overcome the natural repulsion between atomic nuclei. EAST employs powerful superconducting magnets to confine superhot plasma within a donut-shaped chamber, keeping it suspended and preventing it from touching the reactor walls. If that plasma makes contact, the reaction collapses. Essentially, it's like holding a tiny piece of the sun inside a magnetic bottle. Why is this important? Fusion is often dubbed the holy grail of energy. It produces no greenhouse gas emissions, unlike fossil fuels. It generates no long-lived radioactive waste, unlike nuclear fission. And unlike renewable sources like solar and wind, fusion isn't dependent on weather conditions. If perfected, fusion could provide virtually limitless clean power, revolutionizing global energy systems and helping humanity combat climate change. China is not alone in this race for fusion energy. The European Union, the United States, South Korea, and Japan are all conducting advanced fusion experiments. The ITER project in France represents the largest collaborative fusion effort in history. However, China has emerged as a leader, pushing technological boundaries with EAST and developing the CFETR, the Chinese Fusion Engineering Test Reactor, which aims to pave the way for the world's first commercial fusion power plant. What could we achieve with an artificial sun once it's fully developed? Imagine clean, stable electricity grids free from carbon emissions. Picture desalination plants producing abundant fresh water for growing populations. Consider fusion-powered spacecraft that could drastically reduce travel times across the solar system. Think about industries powered by carbon-free, high-energy processes. In December 2021, EAST set a world record by maintaining plasma at 70 million degrees Celsius for 1,056 seconds, nearly 18 minutes. This breakthrough demonstrated that long-duration stable plasma is possible, marking a critical step toward viable fusion power plants. Such case studies prove that fusion is no longer just science fiction, it's inching closer to reality. However, significant challenges remain. Fusion reactors require enormous energy to initiate and sustain reactions. Currently, no experiment has achieved net positive energy, more output than input. Additionally, materials capable of withstanding extreme heat for extended periods are still under development. Commercial-scale fusion plants may still be decades away. Despite these obstacles, optimism is on the rise. Advances in superconducting magnets, AI-controlled plasma, and global collaborations are accelerating progress. Many experts believe we could see the first operational fusion power plants by the 2040s. If China's artificial sun and other global projects succeed, fusion could become the backbone of humanity's clean energy future. China's artificial sun isn't merely a scientific experiment. It symbolizes hope for limitless clean power. The progress made so far illustrates what's possible when nations invest in innovation. The dream of capturing the power of the stars may one day illuminate our cities, fuel our industries, and transform our planet forever.